Hi, everyone. So, today we're going to be talking about porosity, permeability, and in a later video, we'll focus on capillarity, but they're all related. So, let's talk about what porosity and permeability are. Before that, let's talk about the Earth's spheres. We have four spheres of the Earth. We have the lithosphere, which we talked about in our previous lessons. This is the solid part of the Earth. We have the atmosphere, these are the gases that surround the Earth. We have the biosphere, which is all life on Earth, and then we have the hydrosphere. This is all the water found on under and over the surface of the Earth. Today, we're focusing on the hydrosphere, all water found under and over the surface of the Earth. So, how much water do we have on the Earth? 70% of the Earth's surface is covered in water. Please remember this number. Oceans have 97.5% of the water on Earth, land has 2.4%, and the atmosphere has less than 0.001%. So make sure you have your note packet out, your Earth history note packet, and in the third page, you'll find this packet or this sheet. And this is already given to you, I believe. The hydrosphere has 70% of Earth is covered in water. That's the hydrosphere. So go to your worksheet and go to question number 1. This is the porosity and permeability worksheet. Which sphere of Earth covers approximately 70% of the Earth's surface? Go ahead and pause this video and answer this question. The correct answer is the hydrosphere. The hydrosphere contains 70% of the Earth's water. So before we move on to and talk about more about water and porosity and permeability, we need to go back to what sorting is. Remember, sediments that are sorted are grouped by the same size and shape. For instance, this would be well sorted because all or most of the sediments are about the same size and shape. Unsorted means the sediments are grouped by a mix of different sizes and shape of sediments. So, for instance, this would be very poorly sorted or unsorted because all the sediments are different sizes and shapes. Okay, and that's important when we talk about how water travels or seeps down in the ground when it rains. So let's talk about permeability. Permeability is the ability of water to flow through a soil. If you need to write this down in your notebook, I encourage it. That's optional. So, permeability, the ability of water to flow through soil. So, say I have a couple sediments. Over here, you can see there's no space between pore space between the sediments. Here we see connected pore space between the sediments, and here we see even more connected space between the sediments. Which one do you think will let water go through better, or give water the ability to flow through these sediments or soil? The correct answer is this: connected pore spaces. So that's why when pore spaces are connected, there's links between the space so that water can flow through. This place has a high permeability. Water can permeate or move through the connections the space between the sediments. And that's why sorted sediments have high, going to talk about porosity later, but sorted sediments have high permeability, meaning if all the sizes and shapes of the sediments are about the same, there's more pore space between the sediments for the water to flow through. That's why it has a high permeability. But with unsorted sediments, if we have different sizes and shapes of sediments, the smaller sediments will likely block those pore spaces and water can't flow through as easily. So sorted sediments have high permeability and unsorted sediments have low permeability. So let's write that down in your notes. Permeability is the ability of water to flow through soil. Porosity. What is porosity? Porosity is the amount of space between sediments. So permeability is the ability of water to flow through a bunch of sediments, but porosity is how much space we actually have between the sediments. For instance, in sorted sediments, we have lots of space between the sediments, so we have high porosity. And in unsorted sediments, there's not much space between the sediments, so it has low porosity. Very similar to permeability, right? If you have high porosity, you also a lot of times have high permeability. If you have low porosity, most of the time you'll have low permeability. So go and write this down in your notes. Porosity is the space in between sediments. So, and it's both of them, permeability and porosity, are affected by sorting. I'll write this down as well. Remember, sorted sediments have high porosity and permeability, unsorted sediments have low porosity and permeability. Porosity is not affected by particle size. So, this container and this container and this container, they all have the same porosity. They're different sizes, but since in each container the sediments are well sorted or around the same size and shape, they all have a good amount of space between them that water can flow through. So each container has an equal volume of sediment and equal pore space. Remember this. Let's write this down. Porosity, they're only affected by sorting. So pause this video and try question number 2. Which statement best describes the porosity that was found for these 3 samples? A A had a greater porosity than B and C. B had a greater porosity than A and C. C had a greater porosity than A and B, or all 3 samples had the same porosity. The correct answer is D. All samples have the same porosity because, yeah, they're different sizes, but size doesn't matter when it comes to porosity and permeability. What matters is sorting. Since all 3 samples are well sorted, they all have the same porosity. Pause this video and try number 3. The diagram below represents cross sections of equal size beakers A, B, and C filled with beads. What statement best compares the porosity in these 3 beakers? Beaker A and Beaker B have the same porosity, and Beaker C has the least porosity. Beaker A and Beaker B have the same porosity, and Beaker C has the greatest porosity. Beaker B has the greatest porosity. Beaker A has less porosity, and Beaker C has less porosity. Or Beaker C has the greater porosity. Beaker B has less porosity, and Beaker A has less porosity. The correct answer is A. Beaker A and Beaker B have the same porosity, and Beaker C has the least porosity. Think about it. Beaker C is unsorted or poorly sorted. Beaker A and B are well sorted. All the sediments are about the same size and shape in these 2 containers. So both of these 2 containers, A and B, have around the same porosity or even high porosity as well as permeability. But for C, since it's unsorted, the particles can't there's not much space between the sediments and water can't flow through as well. And that's it for this video. In the next video, we'll talk about